our title is cracking. Cracking is an important part of our petrochemical industry. The concept is there in our petrochemical outputs from distillation of crude oil. There are many molecules which are big, like asphalt, bitumen is a big molecule, but it is less fruitful, less useful. So we can break it down and get octane, which is a fuel. So we are breaking bigger molecules into smaller ones using the idea less useful, heavier molecules to more useful, lighter ones. Please
Okay.
copy this screen.
Yep, copied.
So this is a very common technique in our industries, in our plants, where we break down heavier molecules. And what is the theme? What is the theme? Less useful, heavier molecular units are broken down to more useful lighter units. So let's make our next concept. What is the benefit of doing this job? What is the benefit of doing this job? You can crack down to lighter molecules which are more useful. You have to copy this.
Okay.
Have you copied it? Shahir, have you copied it?
Yep, copied.
Now the example is there. Asphalt. Asphalt is that black compound which you are putting on a road for road carpeting. That compound is less profitable, so we can convert it into octane, which is a fuel, and it is more useful. You have to copy this screen.
Okay.
So now can you give me the concept back, Shahid? What is cracking?
It's the breaking of larger or sorry, longer chain hydrocarbons into shorter chain hydrocarbons.
Hmm. There are two main types. One, thermal cracking, and second is catalytic cracking. Thermal cracking at the name. We do it by heating. Catalytic cracking is using a catalyst where we get a carbocation which is actually carbonium ion, and this is the mechanism for that. So we break the carbon to carbon bonds, and after breaking, we can get smaller fractions. There are two methods. So you have to copy this screen now.
Yeah, done. Okay.
What is a carbocation? It is an ion. It is an ion with a positive carbon atom. This is a very important topic when it comes later in unit number 2. And carbocation is also read as carbocation as a rough language. It is a carbonium ion. It has a carbon with a positive charge. It has a carbon with a positive charge, and we can use it in our catalytic cracking. You have to copy this screen now.
Yep, done.
This is the summary sheet for thermal cracking. The details are not required in our AS chemistry. High pressure, 7,000 kilopascal, high temperature in this range. What is a free radical? Can you tell me back what is a free radical?
It's basically an ion that attacks
Is it an ion
normal.
or it's a neutral atom?
It would be an ion because it has an electron that's free.
Make a concept free radical. Free radical is not an ion. It is produced by homolytic fission. What
Okay.
is a free radical? It is a neutral atom in our organic chemistry. The bond breaks and both the atoms take away their own share and go away. You have to copy this screen now.
Okay. Yeah, done.
What is homolytic fission?
Yes. Homolytic fission is when basically a molecule or like a bond, sorry, is split between like let's say a diatomic molecule like chlorine, which
Hmm.
produces two neutral atoms, which can attack uh, other basically other bonds and turn them into free radicals, which is called propagation.
Got it. So will it be right to say that homolytic fission produces free radicals?
Yes.
Good, very good. Produces mostly alkenes for making polymers and ethanol. It also produces hydrogen in the Haber process. I hope you remember that Haber process was in our O level also, the ammonia Haber process. So you have
Yeah,
to update, the same sheet.
done. Done. Yeah.
So please copy these examples.
Okay. Yeah, copied.
Good. So we are done with this thermal cracking. Thermal cracking is just like heating. Catalytic converter conditions vary actually, but one sample is there, slight pressure, high temperature, zeolite catalyst. Here, carbocation is involved, but right now we are not going towards that. But I hope you remember heterolytic fission. First, you copy this, the data sheet.
Yeah, copied.
So it produces branch cyclic compounds which are used for motor fuels. Catalytic cracking is actually used in a lab also, but its main application is for our petrochemical industry, which is quite famous in our Gulf side. Now give a new heading, petrochemicals.
Okay. Done.
What are petrochemicals? These are the composition. This is originally a story which I am sure you remember from O level, that crude oil was discovered a long time ago, but initially no one knew that this crude oil contains so much. It was apparently a dark black mixture, and it is viscous, and normally it was like a useless stuff. But now we know that it is a composition of many useful compounds, mixture of many useful substances. We use fractional distillation. In that process. Can you recall what is fractional distillation? You can look at the screen also.
Yeah,
What is
fractional distillations like the separation of hydrocarbons according to their melting point and melting and boiling points, right?
good? These are some famous outputs: gasoline, naphtha, kerosene, gas oil, lubricating oil, fuel oil. So petrochemicals are actually a mixture of many useful compounds. So right under it, petrochemicals, right under it, it is an industrial phenomenon. It is an industrial process where different fractions of crude oil are used now. Right under it, that the most common technique is fractional distillation. The most common technique is fractional distillation. Now give a new heading: cycloalkenes.
Done. Yeah.
Cycloalkanes are like ring compounds. They are normally ring compounds. For example, the famous example is cyclohexane. So give the heading cycloalkanes and write under it, for example, copy this example screen.
Is benzene ring also one of them? Right?
No, benzene ring is not in our unit 1, but benzene ring is a different, even benzene ring is actually not alkene. We are presently talking about alkane family.
Okay. No, but then like a cyclic hydrocarbon.
No, it has a different concept. It is called acyl halide, acyl compound. There is a circle in the ring. Whenever you look benzene in your past paper,
Yeah.
it is a ring with a circle inside.
Yes. Correct.
Have you copied it?
Yeah. Copied.
Good. Now give a contrast. No need to copy it. How in the paper you can you can identify the difference between cyclohexane and benzene.
The
Can
ring.
you look at the screen? There is a ring.
That's for the 3 double bonds inside benzene.
But in a so-called 3 double bond, but actually benzene is a resonance cloud. It's a type of resonance system. So we have done all the main reactions. I have to do some one or two concepts which are related to general pollution. This was because pollution they think is very important, and in Edexcel they give special attention to pollution. Now let's try some questions, because I always tell you that questions is the main criteria. That is why I have been telling you to buy the books, print, or either print them out. Actually, without the questions, theory is nothing. Theory cannot do anything until you have done a good range of past paper. I think around, say, at least 2015 to 2000, at least 2015 to 2022. Normally, people go even from behind also, and at least 10 years past paper have to be done. But topicals are advantages because you do one topic, you prepare it, and you do the questions. Let's try a question. Some alkanes are used as fuel for transport. Crude oil, which is a mixture of hydrocarbon, is the major source of these alkanes. Crude oil is processed by fractional distillation, cracking, and reforming. What is reforming? Reforming is the reverse of cracking. Reforming means that you can rearrange the chain structure. You can make a straight chain compound into a closed chain. You can break a ring. You can reform the ring. Fractional distillation produces fractions which contain molecules of a similar boiling temperature. Molecules containing 6 carbon atoms are found in both the petrol fraction and the higher boiling kerosene fraction. Identify by name or structural formula the unbranched alkane with 6 carbon atom found in kerosene.
Six carbon atom in kerosene. Now, kerosene,
Can you remind with me all the carbon atoms in alkane?
what do you mean? What?
The
The
alkane family.
yeah. What do you mean by carbon atoms? Like what?
Carbon atom is a number, na? But can you remind for me the alkane family? Methane, ethane.
Yeah, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane.
Very good. So now the question is solved. You have told me. He says unbranched and he says 6 carbon. So whom he's talking about? You have already told me the whole family. 6 carbon.
Yeah.
So
So
what?
6 would mean hexane.
Very good. It is hexane. What is the general formula for alkane? I'm writing it for memory call. What is the general formula for alkane? Look at the screen. Please reply. What is the, I make an arrow also now.
Yeah,
What
that's the
is the
general
general
formula.
formula of alkane?
CnH2n plus 2.
Okay, but replying quick now because we can't actually wait for reading a screen. So can you tell me if n is equal to 6, what would be the formula?
The formula would be C6H14.
Very good. Explain why isomers of alkane in A part 1 have lower boiling temperature and so are found in the petrol fraction. This is the second question and it is 3-mark question. Read the question again because chemistry needs good concentration.
Yeah.
Branched isomer and chain straight lines ones who has low boiling point. You have to remember that greater the number of branches, weaker the intermolecular forces. I hope you remember when you talk about alkane, what are the intermolecular forces in alkane? I'm writing on the screen also.
Yeah, straight chain have higher boiling points.
No, alkanes. What are the intermolecular forces in alkanes?
Between carbon and hydrogen.
No, I'm asking the name. Name. There are intermolecular forces are like hydrogen bond,
Van der Waals.
van der Waals forces. Intermolecular forces in alkanes are van der Waals forces. And now, what is the second memory? Chemistry works on memory now. What is the second memory? Greater the number of branches, weaker are the van der Waals forces. So lower the BP. Can you repeat for me? What is the concept sequence? I repeat once more. Greater the number of branches, weaker are the van der Waals forces, and lower is the boiling point. Now, can you repeat for me?
The greater. Wait. Could you just repeat it once more? Just.
Let's write together.
Yeah, could you repeat?
Greater. I'm writing it, and you should write with me in your notes. Now, this is the concept. Please copy it.
Copied.
Now, help me to answer the question.
When there are more branches, the van der Waals forces are weaker, therefore lower boiling point.
It's a 3-mark question.
Yeah, so the more the branches, the weaker the van der Waals forces, which means the boiling point will be lower than straight chain hydrocarbons.
Good. But you need to make a paragraph now. Whenever.
Not necessarily though. I mean, if it covers the 3 points, wouldn't it be marks anyways?
No, you have to. No. You can't write in this format. Edexcel, Cambridge.
No, not this format. I'm just saying in sentences, if it covers the 3 points, it should be all 3 marks.
No, you need to make a chemistry paragraph. And I tell you 2 important points here, because obviously you have to sit for later in the end of the year. You are going to sit for the Edexcel main exam. Okay, school exams are fine. School exams are okay by that approach. Remember, when you answer a question in our board exam, in our CIE or Edexcel or any board exam, remember 2 important rules. Always link the question. Always link the question. Okay. Second important concept, never compromise on chemistry terminologies. You can't replace them by any of your own words. Van der Waals forces are van der Waals forces. No other approach, no other word. So remember two very important concepts. Always try to link the question, just like here, he's talking me, read the question again. Explain why isomers of the alkane have lower boiling temperature and so are found in petrol fraction. So you will answer to the examiner. You will say that the isomers of the alkane in petrol fraction would be branched isomers. Branched isomers have weaker intermolecular forces due to their less packing up, and this decreases the boiling point. You need to make a paragraph, you need to link the question, and never ever compromise on chemistry terminologies. Otherwise, no need to say. You must have seen, must have heard, just like I think a month ago, Edexcel results were there. And you can ask your seniors that what results they got. Many people suffered because Edexcel marking level is very high.
Okay.
no comparison with O level, because what happened in O level, they are always lenient. Now, during cracking, carbon to carbon bonds are broken. Explain the two major reasons for cracking hydrocarbons. You've done this topic today with me. So can you answer this?
To make them more useful, basically, because smaller chain hydrocarbons are used in different processes. Okay, so like for example, for fuel and for roads. That's one reason, I think. Second reason, not sure. First reason would be they're more useful as
Yes, very
shorter
good answer.
chain.
First
Okay.
reason is to the point. First reason is to the point. Cracking converts less useful, heavier hydrocarbons into more useful hydrocarbons, more useful alkanes. And you have mentioned, and that's very good to remember, that the main approach is what? Look
The
at
main
the screen.
approach is fuel. Yep, yep. Okay.
So now I give you a concept, okay? That concept will be very helpful for you. And you can always try to remember this concept, that hydrocarbons worldwide go into branches. One, fuel, and second, they go in where? They are used in petrochemicals. Petrochemicals are those chemicals which are obtained from hydrocarbons. They are used in different industries, and a huge industry is now there. I'm not talking about pharmaceutical for the time being because it's not in my course directly, but for knowledge, you know that these medicines, if you have a taste of looking the name of the medicines, Shahid, are all
Yeah.
these medicines organic?
Yes, like aspirin. Aspirin
Majority,
is yeah.
majority, whenever you see the generic name, I'm not talking about the trade name, Poston, Panadol, no. Whenever you look at the name, phenol, chloro
Yeah.
compounds, benzene, so these are actually organic. So let's make our concept again. What are the two important applications of hydrocarbons? Look at the screen. What are the two important applications of hydrocarbons?
Fuels and petrochemicals.
Very good. Now reform your answer 1B.
Okay. The first major use of hydrocarbons would be for to create smaller chain. Wait, sorry, I'll just reword.
Smaller chain
the re
hydrocarbons, smaller chain
the
alkanes
reason, yeah,
used.
the reason to crack larger chain hydrocarbons into smaller ones are because they are more useful. Two major examples of these will be one, fuel used in vehicles such as cars, etc., and petrochemicals used in
I
uh,
define, no, you're right, Dil here. Take second number two, and petrochemical, put it separately, because look, can you see he has make it bold?
yeah, yeah,
It means you will number na one
okay.
and two. Now start number two. Reason number two.
Reason
Heavier
number two is
hydrocarbons are broken down to smaller hydrocarbons as the feedstock. As the feedstock for what?
petrochemicals.
Petrochemical. Okay, this is how you have to answer the questions. You have to be very formal in chemistry. Now MCQ comes. MCQs is another style of doing questions. Which of the following changes to the proportions of organic molecules within a fraction results from the reforming process? What is
Okay.
reforming? It's a process of changing the molecular order, change
Yep. Why changes properties? Would it be decrease, increase?
I think I should discuss with you reforming because I am now a bit confused because I think reforming was not in O level. Cracking was there, polymerization was there. Now I'm not remembering it. I'm not sure if you have done it this or not. So we have to do one or two little topics. Let's keep reforming in our agenda.
Okay.
This question is about alkanes. I have left that question. The reaction of ethane and chlorine in UV radiation produce chloroethane. The reaction is classified as what?
Would this, wait, no, this won't be initiation because it's not a free radical.
No, it is not
That's how.
initiation. Remember,
Yeah, yeah,
initiation.
it's not initiation. It's between, that's between free radicals, anyways. Like,
Hmm,
it's
but
splitting
it
the,
is
but
not
anyways,
addition. It is not addition. It is not
yeah,
elimination.
it should be substitution because an H goes to the Cl and a Cl goes to the C2H6.
Because what was the name of this topic when we were doing it? Was named as free radical what? Free radical?
Substitution? I'm not sure.
Free radical substitution. Very good.
Okay.
The black smoke produced from the incomplete combustion of alkane. What is incomplete? Does it mean we have supplied limited oxygen for using
Yes,
catalytic converter? What is incomplete combustion?
carbon monoxide is formed.
Very good. But remember, in this combustion, the main issue is what? Limited oxygen.
Oxygen. Yeah.
If you burn something in open air, it's complete combustion. So if you burn something in limited area, it is incomplete combustion. Carbon part, okay, fine. The black smoke produced from the incomplete of the alkane fuel is, uh, this is a good concept to remember. The word smoke and the word black.
Okay.
Smoke is actually white. Smoke is not black. That's why he's using the word black. Oxides of nitrogen, I give you the example NO2, NO, and you know they are colorless. Oxides
Yeah.
of
Okay.
sulfur, I give you the example SO2 and SO3. They're
It
also
should be
colorless.
carbon particulates because it's carbon soot, right? That's
It's
produced.
carbon soot. That is why people get a severe cough.
Yeah.
A reaction of hexane is shown below. Is it a skeletal structure or reforming?
Yes.
I'm sorry. I think
This
reforming
would be,
this
yeah,
reaction.
I was gonna say this was decomposition, but like it's reforming because
No,
it
no.
just,
Actually,
yeah,
reforming. This is a good point to explain a bit of reforming. You can see this is an open chain,
yeah,
and this is a ring.
ring. Yeah. So at
The
first it's
open chain
C6
ring, and this is called
reforming
reforming.
because like the carbons form a chain and loses the hydrogen bonds, right? That's why hydrogen is
We
produced.
break the corner bonds, and just like when you are wearing a necklace is originally a straight chain. You make a loop of it and you wear it. This is called reforming. This is called.
Reforming, yeah.
Now the skeletal formula of decalin is, the molecular formula of decalin would be how much? Remember, all vertices are carbon.
Yeah.
All vertices are carbon. All empty all empty bonds are hydrogen. Remember this master rule. All vertices are carbon. All vertices are
Carbon.
carbon. Look, I have made carbon. All free bonds. How many bonds carbon make?
4.
4. So I'm filling the bonds on every point. Look. Can you see this? All 4 bonds are complete for this carbon.
Yes.
Okay. And this one will have 1 H. This one will have 2 H. This one will have 2 H.
It should be C10, H18.
And if you keep on counting,
C10, H18.
okay, this one will have 1.
2, 4,
This
8,
one
8,
will have 2 hydrogen. This one will have 2 hydrogen. This one also have 2 hydrogen. How many carbons total? 10. But every option is 10.
Yeah, C10, H18.
Have you counted it?
Yeah, I've counted it before. Yeah.
Very good. This question concerns the combustion of fossil fuel in power station. What are these fossil fuel? Are these crude oil, etc.? Do you remember that story or have you heard about it? How crude oil is formed?
The fossils under high pressure.
Under high pressure, they long time, they gradually convert into this. One type of power station uses the combustion of methane gas to generate power. Incomplete combustion of methane.
Yeah.
Can you help me? CH4
Plus O2. Actually, no, it will just be plus ash, and then it will produce CO. Plus H2O.
So how should I balance it?
Four hydrogens, which means 2.
Hydrogen is 4.
Yeah. So like 2 hydrogens. So like 2 H2O, sorry, and then that means you have 6 in total of
How many
split.
oxygen right
No,
side?
sorry, 4 oxygen, so it's 2 O2.
4
Not 6.
oxygen. How 4 oxygen?
2 plus, oh, sorry, 3 oxygen because not CO2. So 1.5 O2.
Fraction here.
Yeah, 1.5 O2.
One of the problems associated with the combustion of some fossil fuel is the production of acidic gases, including the oxides of nitrogen and sulfur. Explain how oxides of sulfur and nitrogen can be formed from the combustion of fossil fuel. Now, this question is never difficult if you remember that actually the fossil fuel contain sulfur contamination, they contain nitrogen contamination. So as they contain sulfur and nitrogen, they burn in oxygen and they form SO2, SOx and NOx. What is the concept? Fossil fuel are coming from the earth. By nature, they contain contamination of sulfur compounds and contamination of nitrogen compounds. So when you burn them, you will get oxides of sulfur and you get oxides of nitrogen. Can you repeat the answer for me? Can you repeat the answer?
When the fossil fuels are burned, they make sulfur oxides and nitrogen oxides.
No, but this is the
Right.
question of why he says,
Okay.
explain how. You will tell that fossil fuel by nature contains sulfur and nitrogen contaminations. So that is why when you burn them, the contamination also burn down and they produce sulfur oxides and nitrogen oxides. I repeat, you have to write, you have to tell the complete answer. Some power stations use a process of flue gases desulfurization to remove sulfur oxides from the gaseous combustion products. One such process known as wet scrubbing uses a mixture of calcium carbonate and water to react with sulfur dioxide. Two relevant equations are given. SO2 plus calcium carbonate gives me CaSO3. CaSO3 will absorb water, will absorb oxygen to become calcium sulfate. I am using calcium carbonate. Do you remember the normal name for calcium carbonate? It's a
Calcium.
the
Yeah.
relevance of limestone. So why
Yes.
I'm using
Okay.
calcium carbonate?
Again, you said what?
I'm asking
Yeah.
why. What is the purpose of the first reaction?
To remove sulfur dioxide from the
Very good.
atmosphere.
Remove sulfur oxide.
Yeah.
And what is the final product? Can you look at this skin? What is the final product?
The final product will be
I have made a box.
plus CO2.
CaSO4.
Yeah.
Calcium sulfate has some applications in construction, other side of applications. Now read the question. Explain why this process is an incomplete solution to the problem of burning fossil fuels. Use the equation provided to illustrate your answer.
Because calcium sulfate can break down into sulfur.
No. Calcium
No?
sulfate is a hydrated solid and it has to be disposed or transported. That's a problem. Secondly, you should remember that the power stations use a process of flue gas desulfurization. But what power stations were producing? What power
Yeah.
stations are producing?
Sulfur dioxide and nitrogen dioxide.
So have you treated both of them?
No, only one.
Good. So you got the point.
Yeah.
First thing, calcium sulfate has to be treated, to have to be disposed, or have to be sold out. Second, the problem is that in this process, have we resolved nitrogen oxide also?
No,
No.
only sulfur dioxide.
Yes. So we have done this question. Let's quickly do this and then we are winding up. Draw a dot and cross diagram for sulfur dioxide. Can you tell me the formula for sulfur dioxide? Look at the screen.
Yeah. Okay. Dot and cross would be S. Okay. And then you'll have two.
After first write down the formula, then show the bonds. Now you can easily show the dot and cross. Dot and cross diagram can be made in a better way if you keep your periodic table with you.
Yep.
Why?
Opening that.
Because you have to show what? Look at this. What you have to show.
The electrons basically of
Outer
sulfur.
electrons. Okay, good. So you have to make this SO2 for me, the dot and cross, and let's keep it as a homework. You have to show me after the class. Please send me the dot and cross for SO2. We are keeping up to here, and we are nearly done with our organic unit, which is topic number 4, unit number 1. And we can do some questions now because we have to improve our organic. You can see we did only few questions, but look the difference, that the thing we can get from questions. It's okay for today, and we'll inshallah continue in our next class. Thank you.
Okay, that is.